So in this video, we're going to introduce polynomials. The first part of the notes is just a whole bunch of definitions. So I went ahead and I filled in the blanks, and then I'm going to just kind of talk through it in this video. So the first new term we have is a polynomial. Polynomial is a finite sum, which means it ends in the form of ax to the n, where the number in front is any number, a real number, and n, the exponent, is a whole number. So what this means, the takeaway here, is that in order to be a polynomial, there can be no fractions and no negatives in the exponent. So there are going to be some questions that just say, is this a polynomial? If you see a fraction or a negative number in the exponent, then it is not a polynomial. We can have fractions or negative numbers in front, but we cannot have fractions or negatives in the exponent. So that's going to be if it's a polynomial or not. And then we are going to zoom in on polynomials and spend the rest of the chapter talking about them. So some characteristics of polynomials: they have terms. Terms are going to be the parts, essentially, of a polynomial that are separated by addition or subtraction signs. There are going to be two types of terms: a variable term, which is going to be a term that contains a variable or a letter, and then a constant term, which is going to be a term that does not contain a variable. It's fixed. It doesn't depend on what x is or y or r. And then we have a coefficient, which is going to be the number in front of the variable. Now with that, let's look over here to this polynomial to the right and kind of put some actual examples to these definitions. So the first thing is just to note that this is a polynomial. Notice all the exponents are positive whole numbers. I have 4, 3, 2, technically a 1 there, and then nothing. Also notice that the exponents are in decreasing order. We call this standard form of a polynomial. The numbers out front can be negative, but the exponents have to be positive whole numbers. So let's go through and label the terms and each coefficient. So 3 or negative 3x to the fourth, that is going to be my first term because it is separated by an addition or subtraction sign. And then the coefficient for that term is going to be negative 3 because it is the number in front. The next term, 2x to the third, that's going to be my second term. And the coefficient on that is going to be a positive 2. Or just 2. The next term is going to be negative 15x squared. That's going to be my third term. And the coefficient on that is going to be negative 15 because minus 15 is a negative 15 for my coefficient. And then the second to last term, negative x, is going to be my fourth term. And the coefficient on this one is going to be a negative 1. I don't see a number, but I could write that as negative 1x. And then the very last term is going to be positive 19. Now, because that is not a variable term, we don't consider positive 19 a coefficient. It is a coefficient, but we just call that a constant because there is no variable associated with it. So with that being said, these first three, where I've got this bracket, these first four terms are going to be variable terms because they contain a variable. The last term, positive 19, is going to be my constant term because it does not contain a variable. And so that just kind of puts an example down to all of those definitions. And then the other thing that we're going to do in this section is classifying polynomials based on either their number of terms or their degree. And so the number of terms, we have a special name for 3 of them. So if it just has 1 term, we call that a monomial. If it just has 2 terms, we call that a binomial. And if it has 3 terms, we call that a trinomial. So you can see here I've got an example, 1, 2, 3 terms. And so we would identify that or classify that as a trinomial. Another way that we can classify polynomials is based on the degree. The degree is another way to sort polynomials, because as you get further in math, that's going to tell you about the polynomial itself based on the degree. So the degree is the largest of the exponents. If you have more than one variable, then you would add up the exponents. We won't see that specifically in this section, but worth noting because that will be coming later on. And then once you find the degree, the coefficient of the largest degree, we call that the leading coefficient. So here in this example, going back to this one, negative 3x to the 4th, because x to the 4th is my largest exponent, then the degree of this polynomial would be 4, and the leading coefficient would be the coefficient associated with that term would be negative 3. Now we're going to do a couple more examples, but that just kind of, again, gives you more specific examples for all of these definitions. And so that is just a nice big overview of polynomials.